Welcome everyone in the next session of interaction of land use in transportation. In that specific session, in session number 3, we will try to understand that how the urban transportation aims to support transportation demand, which is generated through diversity of the urban activities. First of all our demand is generated from the diversity of the urban activities. So the key understanding of urban activities usually lies in the pattern and processes of the land use and transportation system, which is a bit more high complicated and also involve several factors such as transport system, because in that land use we will try to understand the relation that how the transportation generate more and more demand, which is special interaction, and what is the relation of the land use. So in order to understand, the special interaction is basically the urban activity, urban function, and transportation system and land use. So we are trying to understand the concept that how increase in the urban activities can affect directly or indirectly the expansion within transportation system as well as the land use. First of all, to understand what is transport system. Okay, number one. So the transportation system or transport is actually referred towards infrastructure as well as modes. So through which we can support the mobility of a passenger as well as the freight and logistic as well as the goods as well. So it usually generally expressed at the level of accessibility. So this is the level of accessibility, that how we can reach to one place to from one place to another with much ease. Then the second part is which is related to the urban function. We have the special interaction. So the nature such as origin, destination of that urban function, urban mobility of the passenger. So in the special interaction, we usually consider the attributes of the transportation system as well as the land use factor which generate and attract movement. So we have two main factors. The number one is that how the land use factor, which is basically related to the urban function, and then how it increased. For example, we have generated or we already built one infrastructure for the transportation, but with the passage of time, we need more rapid expansion. So this is relation of the land use factor, which is connected with the what kind of or due to which attracting factor we need more expansion. And then the last part is about the land use. So the level of the special activities and their associated level of mobility, which require or which is basically linked to the demographic as well as the economic attributes. So in that specific session, we will try to understand the interaction of land use and transportation. That chart was generated by my teacher, Professor Wolfers from the Technical University of Munich, Germany in 2003. According to that specific chart, first of all, we need to understand where we have a circle. So that shows basically structure. And then we have process. And then we have the proportional impact. And then we have reciprocal impact. And then counter feedback as well as the reinforcing feedback. Look, that specific portion is divided in the short term as well as in the long term mobility. In the short term mobility, we only want to attract more activities or generate more activities is a result which will increase or which will generate more travel demand, but for the time being. But if we take a look to that specific figure in the long term, so that the three basic urban function or factor are kind of affecting. Number one is land use, second is accessibility, and the third one is the transportation supply. If you look to the land use, so land use is again proportional and process connected with the cooperation planning as well as the land availability. We can increase or we can utilize more land if the land is available. So is in my previous session, as I already explained, that we have many factor, many case studies where the commercial activity is already built. For example, if this is your commercial activity and this is the two-lane road, and we want to increase it to like third one, but here we have commercial activity which is already built from like 2 to 3 decades. So now this is a very big challenge for the urban planner in the form of the cooperation planning as well as the availability of the land. Of course, now we have the requirement to create or build the third lane, but which is not technically possible because your commercial activity or like any kind of a built infrastructure is already exist there. So in that specific chart, we will try to understand the urban development and the transport, which is not simple and which is again not one way, but it is again two-way process which connect two main factors. The one is macroeconomics and the second one is the interregional migration from one place to the another place. So the macroeconomics is actually related to the people when people will move due to for example for the better jobs as well as to build their own economy, stable their own class, and so on. And then we have the interregional migration from the rural to the urban area. So as a result, we create the kind of a more activity. So according to that specific figure, increase in land use. So now, first of all, let me clear that previous explanation so that you can understand that chart uh, in the way in which I want to explain. Okay. Okay. For example, according to that specific figure, increase in land use activity, okay, increase in land use activity, it will increase more activities, and of course, accessibility will also be increased. The transport supply is designed for the specific percentage of the people. So if the demand increases, the same supply will be affected here. Because we are supplying, for example, 100 to the 100 people to access to like 5 different places. And land uses already, for example, use 100 square kilometer area. But if the activities are increased, so there is a reciprocal and proportional impact between transport supply here and transportation demand. So the balance between these two variables is important. If any limit exceed, then reciprocal impact will start here, as you can see here. As I already mentioned, that negative means reciprocal impact. If you look to that short-term place here, so the short-term mobility decisions are greatly influenced due to the everyday activities, such as marketing type of activity, model choice, route choice, and so on. But some aspects are also influenced by the service of that specific transportation which we offer. So if the right quality offer more comfort, then the travel demand, so the travel option will increase. And in the last part, the improvement in the transportation supply here will only possible and we also required, of course, accessibility will increase, but that is connected with the more investment. So more economy is basically concerned here, accessibility and transportation demand. To tackle that specific demand, of course, we can increase that, but what will happen, the economy is concerned. Economy related to land use and economy related to build more infrastructure. So increase in transportation supply will increase the accessibility, and for more accessibility, more land will be required. And then the last part is connected with the land availability. What will happen if the land is not available? So for example, if I give you the example of Beijing city, so Beijing already reached to like underground 13 story, underground 13 story. So you can imagine that how much cost is actually involved there, because the already built infrastructure did not allow to build more infrastructure on the ground surface. So the only way you have to utilize that amount, so then to go underground. But of course, like level 1, level 2, level 3, the more we will go down, so the more cost will actually involve. That that specific chart is divided among that what are the rights of transportation system if we refer it towards the individual as well as the public. So for example, if we try to understand the concept between railway and road, so we can understand that rail track is not the individual option, that is completely public. If it's a national railway, if it's a regional railway, if it's a light rail, even if it's a tram. So this is not, this is completely public. This is not related to any individual person. Of course, if the country prioritize the same track so that the private investor can actually run their own function. But again, the main entity will be is kind of a related or concerned with the public as well as with the government. But if we try to understand the concept of a road, so that is completely individual, such as private car, motorbike, bicycle, pedestrian, and so on. But if you try to understand the concept of the public, so then buses and taxis are only considered as the public mode, which is for the general public. Transportation offer two things. The first is network. The second is services. The network is basically refer or generally connected to the links, nodes, in lines, while in length. And the operation is or the services include the movement of the goods in people, also through different modes such as rail, road, air, cable, and sea. So transportation services can be divided into different areas such as infrastructure, vehicle, and operations. But if you try to understand the network, so the length have characteristics such as speed, that one, speed, capacity, frequency, and travel time. So those are connected directly to the infrastructure. So now the purpose of that specific chart, just to understand that within the radius of 2 kilometers, we have the combination of a different kind of a services is available. This is from the concept from the France, from the transportation network of the France. As you can see here that within that specific district, so we have so many options. So like this is called node, or we can call it origin, or we can call that destination. And the one which connect two nodes together is called length. Okay, and that one is called nodes. Okay, this we have already explained here as well, which is combination of different nodes. So now you can imagine that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, almost 10 nodes, almost 20 lengths. So you can imagine that that specific area have the better connectivity or connectivity. So now we will understand that which place we can consider is that that specific area is betterly connected and that specific area is poorly connected. But first, let me give you the example of network topologies with different visualization concept. As you can see here, that is the example of Copenhagen, number one, A. This is example of London City. This is example of Paris. This is for from the Munich city. This is from the San Francisco. And this is from Toronto. So and so on. So now you can imagine that every city topology is completely different. Its structure is completely different. So you can see here that is completely different. That city looks completely different. That one have different legs here. That is somehow kind of a raster network. That is circular network. And that is completely somehow looks like rectangular. And that is little bit more centric. So, and that specific session, we will try to understand the network layout, structure, as well as its topology. And I would strongly recommend to read that specific article, which was published in 2013. The article title is Topological Structure of Urban Street Network from the Perspective of the Degree of Correlation. Okay, so you should understand a bit more detail from that specific article, which is published in 2013. So a network topology is the physical as well as the logical arrangement of different nodes as well as the connection. So nodes usually include different kind of a the origin point is called nodes, while which connect the two network together, the two nodes together is called links. Okay, so this is just typical example. That specific area is connected and is best for the public transportation, or you can call that this is our public transportation line, where we have the underground railways line as well as the inter-regional line as well. And then we have the concept for the private car, that how they are connecting the are reaching to the city center. Okay. And then we have the concept of the non-motorized transport as well, that how the non-motorized transport. So when we connect all those figure 1 plus 2 plus 3 together, then we can get the network of a one city which connect public transport network, also connect private as well as the non-motorized transport. And I will also recommend to all the students to go through that specific article, the topologies of the city, which is very amazing, and it's a very well documented and well written document as well. Now we are trying to understand the connect of the concept of connection, connectivity, or the connexity. So connectivity or connexity is defined as the measurement of the system or of a street which have the multiple routes as well as the connection which serve the same origin as well as the destination. In a very simple word, that how a high degree of connectivity means or take place of the people from point A to point B. For example, this is our point A and this is our point B. Okay. So now we have the very clear formula that the quality of interconnection we can determine from the number of links divided by the number of nodes. So now you can see here, this is node 1, this is node 2, and this is link 1. So number of link we have 1, and the number of nodes we have 2. So 1 by 2 we have 0.5. So you can imagine that area, if the quality of interconnection is 0.75, for example here, if it's up to that mark, so it's okay. But if it's below than that, that means that it's not connected. Okay, so if we take example of that part, 1, 2, 3, 4. So for example, this is connected somehow 1, 2, 3, 4. This link is connected with that, and that is also connected reciprocal as well. So now we have node 1, 2, 3, 4, 4 nodes. And how many lengths we do have? 1, 2, 3, 4, and then 5, and then 6. So 6 by 4 is equal to 1.5. So that means that that area is betterly connected. And the same example can be seen from the with the naked eyes as well, as you can imagine that only those two nodes are connected with a single line and do not have any option. But if we take a look to like that example that is connected through square and then through the interior part as well. So which make it more connected. And if you imagine that this is the real-time figure, so those people have the most better connection and connectivity from to go from like that place to like that one and have from point node 1 to node 3. Okay. This is the slide from the previous figure. Now I would like to give the class task to every individual who is listening to that specific lecture. As you can see here, before we have only one node, and then we have now different nodes in like different lengths. So you can imagine if we can increase its resolution or image quality. So you can consider those one nodes and then we have connectivity. So then you can imagine that what does it mean by the quality of interconnection or what is the role of connectivity or connexity. That is the typical example of the Munich, German city, which is completely built on the radial ring system. Okay. Radial ring system. Okay, so now we will try to understand the different network topologies. The first point we will try to understand is the spatial development. The spatial development that how the origin, context, nature, and population are actually built and how different locations are connected with each other. So if you look to that specific part, that is monocentrically oriented, that one monocentrically oriented. That means that the same center is again divided and connected with the very smaller and shorter part. So that will increase a very huge burden at the very center part. Okay, the first one. If we try to understand the transportation part, so this is very good structure for different transportation modes. For example, you can connect that part with like high-speed railway, that part with underground, that part with tram line, that part with like buses. So you can make a different connection, and it's the hierarchical system of the major radial axis, or like which we call the arterial network, as well as the ring, which is very good for the walking within that specific city center here. And if you try to understand its orientation, so it's a bit spontaneous orientation, which is difficult to understand, and very less people will be familiarized. So the local identity of those places will also be affected. This is the raster network, which happens after the urban sprawl. As you can see that each and every block is connected with each other here. For example, you can even take the quality, the number of lengths divided by number of nodes as well. So you can imagine that how much well connected that specific part as well. So we have different local and different regional center, which is almost everywhere, as you can see here from like that specific figure as well. So we have different locations, different spots here. And for the transportation, it will be a bit difficult to operate, especially for the public transportation. So eventually people will prefer towards walking as compared to public transportation. But if you try to understand in the form of orientation, so that is very simple, very logical, and very structured nodes. Okay, logical, very simple to operate. For example, you are living here, you want to go here. So you can even take that specific route and directly go here, or you can go from here to here as well. And it's also enable you to like use different alternative options. Okay. The next path we have the orthogonal diagonal system. So that is basically the combination of raster as well as the radial ring. Raster network plus radial ring. If you see here, at that part, it is completely radial, and at that part, in the outer skirt, it's completely raster. So if you try to understand the spatial development, uh, we have the Foster Development Center, which exists almost in the. It is again very much connected, as you can see here. Every network, every node is connected not only through outer way, but is also connected through the inner way as well here. So you can imagine about the interconnection of the quality as well as of the connectivity of the each nodes. Here. If regarding transportation system, that is very much ideal for the walking a long road without tendency to like detour. And if you try to understand orientation, there will be a bit disturbance in the form of orientation because the diagonal system is connected within the raster system, because it have the disadvantages of like raster as well as of the radial ring system as well. That specific slide, we will try to understand the operation in services, that how it can affect on the that chart. That here we have the flow, and here we have the speed. Okay. First of all, try to understand the different nomenclature of that specific system. So we have the constraint for the speed as well as of the capacity, and we determine the flow from the average traffic flow multiplied by the speed, which we determine in the kilometer per hour here. And traffic density is determined from the vehicle per kilometer. So this is the speed which we call maximum capacity here, and this is the speed threshold. And that is the maximum capacity of the speed which it can operate, so which we call the velocity optimum, so which is between 70 to 72 kilometer per hour. And that part here up to here, this is our uncongested flow, and at that part, this is our. Now the situation is going towards congestion, and here at that point, this is our which we call the breakdown. So at that position or at that specific speed, the maximum number of vehicle within kilometer already reached. So now we have kind of received that optimum level of the speed. So after that level, after 4,000 vehicle per hour, after that, then we will reach to the congestion part. This is our congestion part. Or in a very simple word, if you want to understand, so below that 60, 62 or 70, all those vehicles which are below than that are basically, if you see here, so that here we have the operating speed of 25, here we have 35 or 40. So, but its operating should be somehow between 70 to 72 kilometer per hour. Basically, it shows the maximum traffic flow which is related to the optimum traffic density according to the flow and velocity diagram, which exists between two different regimes, meaning it's possible to have two speed at the same traffic flow, but this traffic flow is somehow between uncongested as well as between the congestion, which we call stable as well as the unstable flow. It also shows that the Q diagram from that specific chart, we can also determine the number of the vehicle which are between or within the stable region as well as between the unstable region as well. Specific assignment to every student that submit the same assignment and discuss its advantages and disadvantages of the each for the public transport network. And also you need to determine the connectivity as well. Okay, so this is your assignment. If you have any question, you can get back in